Science. Science is as real as life itself. The role of science in the society cannot be overemphasized. The foundation of technological advancement is based on the understanding of good science. The beauty about science is that it is an evidence-based approach to facts, and these are facts that can and have been tested. The major sciences include chemistry, biology, and physics, at least at this level. Later on, these branches shall be broken down into distinct disciplines. In this production, we shall deal with chemistry. Chemistry is a branch of science that deals with the study of the structure, composition, properties, and behavior or reaction of substances. Everything you see around is a product of some sort of chemical reaction. Reactions occur when two or more substances combine under certain conditions, or when a substance is subjected to certain conditions. A simple example of a reaction is rust. Rust occurs when iron combines with oxygen under moist conditions. In chemistry, we conduct experiments, make observations, and analyze them. We then interpret them, and from that one can be able to make conclusions. There is no room for guesswork in chemistry and science at large, and any assumption is based on good science. Chemistry finds application in medicine, pharmaceuticals, food industries, agriculture, and manufacture of synthetic materials, amongst many others. And we start with the very basis of chemistry, that is matter, and matter is anything that has mass and occupies space. Matter can exist either as solid, liquid, or gas, and these are called the three states of matter. These states are interconvertible by either heating or cooling. When a solid is heated, it melts into a liquid. On further heating, the liquid will vaporize into a gas. When a gas is cooled, it condenses back into a liquid, and on further cooling, the liquid will freeze back into a solid. Mass is the quantity of matter in an object, and volume is the amount of space occupied by an object. Let us look at the properties of matter, and we start with a solid. Suppose a solid is immersed in a jar full of water. It displaces some water, and this means that the solid has volume, that is, it occupies space. If you place the solid on a weighing balance, the readings change. That means it has mass or weight. If a solid is transferred from one container to another of different shape, its shape does not change. In summary, we say solids have definite shape, volume, and mass. How about liquids? If a beaker is weighed and then water is added, there is an increase in mass, meaning liquids have mass. If a definite volume of water is transferred to containers of different shapes, it assumes the shapes of those containers. However, its volume remains the same. In summary, liquids have definite volume and mass, but not shape. And how about gases? If an empty balloon is weighed and then inflated and reweighed, there is an increase in mass, meaning air has mass. The balloon also increases in size, which means the air occupies space. If you squeeze a balloon, its size or volume reduces, and when you release, the volume increases again. This means that the air inside can occupy a larger and a small volume. In squeezing, the shape of the balloon changes as well. In summary, gases have definite mass but no definite volume nor shape. Well, the next thing we look at is the mixtures, and naturally, matter exists either purely or as a mixture of many substances. For example, the soil is a mixture of many substances including minerals, the major one being silicon, humus, weathering rocks, and so on. However, in these combinations, each substance retains its physical and chemical properties. A mixture is made up of two or more substances that are not chemically combined. Thus, mixtures are rather easier to separate by physical means, for example, sieving, evaporation, decantation, winnowing, or use of magnets, and we shall come to these methods of separation in the next chapter. Meanwhile, we take a survey of the chemistry laboratory, and chemistry involves practical procedures called experiments. These are conducted in special rooms called laboratories. The laboratories provide conducive conditions for the experiments. Reactions themselves take place in special vessels or containers called apparatus. There are many apparatus, each with specific use, and come in various sizes. Most apparatus are made of inert materials, preferably glass. Why? First of all, the glass is an inert material, which means it has little tendency to react with chemicals it holds. Secondly, the smoothness of the glass material makes it easier to clean. And finally, the transparency of the glass material allows one to see the reactions as they take place inside the vessels. So now we look at various apparatus and their uses. First in the lineup is a graduated beaker. A graduated beaker is made up of glass and it is used for measuring approximate volumes of liquids. For example, the beaker on your screen has graduations on the sides, and it means it can only measure volumes in the multiples of 50 milliliters. Next is a conical flask, and from its name it takes the approximate shape of a cone. Also made up of glass, has graduations on the side, and it's used for measuring volumes of liquids and also holding liquid reagents during experiments, especially titrations. We then have a bottomed flask. A flat bottomed flask is made up of glass. It has a cork at the mouth and it is used for holding or storing liquid reagents. Next we have a round bottomed flask. Like the flat bottomed flask is made up of glass. It has a cork at the mouth and it is used for holding or storing liquid reagents. It can also be used for heating. Why? Because it has a round bottom, there is even distribution of heat and therefore it is unlikely to crack. Expansion due to heating can cause cracking of the flat bottomed flask, and therefore the flat bottomed flask must never be used for heating. And then we have a volumetric flask. A volumetric flask is made up of glass. It has a longer neck than both the flat and round bottomed flask. It is used for measuring definite volumes of liquid. Why definite? Because at the end of the neck you realize there is a mark. So liquids have to be filled up to that mark, and that means the flask is carrying the volume indicated on its wall, and therefore it can only measure one volume. For example, the flask on your screen can only measure a volume of 100 mLs. So you fill a liquid up to the mark and it carries a capacity of 100 mLs only. And then I have test tubes in a test tube rack. Test tubes are used for general lab experiments and for holding small volumes of liquids and also solids during experiments. Simple experiments can also be conducted in test tubes. Test tubes are made strictly of glass. And next is a distillation funnel made up of glass. It's used for delivering liquid substances into apparatus that have narrow mouths. A reagent bottle is made up of glass. A reagent bottle is made up of glass and it is used for storage of liquid substances, especially corrosive ones, those that require long-term storage. Separating funnel. A separating funnel made up of glass. It has a tap and it is used for separating immiscible liquids. We will see the use of that in the next chapter. Next, we have a mortar and pestle. They always work together. They could be metallic or made of clay, very hard clay, and they are used for crushing substances. The mortar is the bowl-like apparatus, while the other piece is the pestle. They are used for crushing substances. Then I have a pipette. A pipette is made up of glass. It is used for delivering definite volumes of liquids. For example, in most cases a pipette would be 25 mLs. It has a mark at the narrow top where you fill a liquid up to that mark and it carries the capacity indicated on the pipette. Most pipettes carry 25 mLs or 25 centimeters cubed of liquids. Next is a clamp and a stand. A clamp and a stand, they are used for holding pieces of apparatus during experiments for stability purposes. A spatula. A spatula is metallic and it is used for scooping solid substances from containers where they are stored. And that is a burette. A burette is made up of glass and it has a tap. It is used for controlled delivery of liquid substances during experiments, mainly titrations. We will also see the use of a burette. We then have stirring rods. They are made of glass and just like their name suggests, they are used for stirring mixtures. Next is tongs. Tongs look like scissors and they are metallic. They are used for holding corrosive or hot substances. And that is an electronic balance, obviously used for weighing substances. And then I have thermometers. Those are two thermometers, liquid in glass. Those are mercury in glass thermometers and they are used for monitoring temperatures during experiments. or strictly taking temperatures. And finally, we have a Bunsen burner. A Bunsen burner is used for heating in the laboratory. We shall be meeting these and many more apparatus as we continue, and we shall be mentioning them and also talking about their uses as we use them. So we now look at heating in the laboratory, and heating is a common procedure in the laboratory. Common sources of heating include Bunsen burner, the ethanol burner, electronic heater, and a candle. Let's see the Bunsen burner. The topic on Bunsen burner is a common source of questions in chemistry, mostly involving the parts of the apparatus, the types and properties of flames, and experiments using the flames, and therefore attention to details is important. First of all, notice that the name Bunsen starts with a capital B always, and this is because it is named after the inventor. You must always write the name as such, and these simple mistakes can be very costly in chemistry examinations. Parts of a Bunsen burner. The Bunsen burner consists of three major parts: the chimney, the collar, and the base. The chimney is the hollow metallic cylinder with an air hole at its lower end. The collar is the metallic ring with a hole of the same size as that in the chimney. The diameter of the collar is slightly bigger than that of the chimney. The base is a thick metallic material where a small hollow metal jet is fitted. Let us turn and look at the uses of different parts. A gas inlet, and this is connected to an external source of laboratory gas by a rubber tubing. The jet allows the gas into the chimney. The collar regulates the amount of air entering the chimney. The air hole in the chimney allows air to enter and mix the laboratory gas. The lab gas and air mix, and when ignited, burns at the top of the chimney to produce a flame for heating. Let's now turn and look at luminous and non-luminous flames. When a Bunsen burner is lit and the air hole is closed, a flame that is bright yellow, large and wavy is produced. It gives a lot of light, and this is a luminous flame as shown on your screen. A luminous flame has four zones. At the bottom side there is a blue zone. Here air rises and mixes with the burning gas, producing complete combustion of the gas. In the middle there is an almost colorless region. This consists of unburnt gas. Surrounding the almost colorless region is a luminous bright yellow zone. Here there is limited air supply and incomplete combustion of the gas occur. The region consists mainly of unburnt tiny particles of hot glowing solid carbon, and it's the region that gives light. The carbon particles form soot that makes the apparatus dirty during heating. On the very outer part of the flame is a thin outer pale blue zone. Here there is complete combustion because the gas mixes with the air. The region is however hard to see. The luminous flame is useful for lighting rather than heating. Conversely, when the burner is lit with the air hole opened, a non-luminous flame is produced. The air enters into the chimney and mixes with the gas, causing complete combustion of the gas. The flame is blue in color and has 3 zones. The almost colorless region just above the chimney is made up of unburnt gas. The green-blue zone above the colorless region consists of partially burnt gases due to insufficient air supply. In the outer pale blue zone, there is complete combustion due to plenty of air. The non-luminous flame gives off little light and is preferred for heating. It is also very noisy. The pale blue zone is the hottest part of the non-luminous flame. The almost colorless region does not burn since it only contains of unburnt gas. Let us now turn and look at the burning pattern of a wooden splint when placed at different levels of the non-luminous flame. Now on the screen I have the non-luminous flames. Suppose a wooden splint is placed at this level of the flame. We have a burning pattern as shown here. Now assuming I take the same wooden splint and place it at this level, the burning pattern would be different, shown here. Now the charred region is the region in contact with the outer pale blue zone, which is the hottest part of the flame. The unburnt region is the one that is in contact with the almost colorless region that contains of unburnt gases.
When thinking about your career and wondering what to study to equip yourself for the working world, MSc is the college to help you make this decision. We have 23 campuses nationwide and a wide range of aligned and accredited programs to choose from. Best of all, easy payment terms and flexible class times. MSc College is your ticket to a better life. Call 0860 672 265 or visit msccollege.co.za.